Very good morning, students. I hope all of you are doing very well at your respective places, and we are very eager to see you all coming over here at Sri Chaitanya Gosala campus, right? So, before these classes started, that time also we all introduced ourselves. So, again, I should introduce myself in case you forgot. So, I am Paul Mitra, and I am also a senior faculty in physics over here at Sri Chaitanya Gosala. So, today we will be taking an important concept of physics. Now, why I am saying important, this chapter which we are going to study or to start with basically, that is motion. That is, you can say, one of the most important chapters of physics. Why? Because as the saying goes that to keep on moving is life, and if you stop, it's death. So same thing over here, when we talk of physics, the real feel of physics comes when you start studying about motion. So till now you have been seeing different concepts of mathematics which are going to be applied in physics, but the real feel of physics comes when you start reading about motion. So today we will be seeing the most basic form of motion, which is called as uniform motion. And before coming to uniform motion, we will be seeing some terminologies or terms, and once you understand them, it will be easy for you to understand the questions also associated with it, right? So again, good morning to all of you who have joined just now. And yes, obviously you will be again read these all chapters when you come here offline, but this will help you give an elementary idea of the concepts that will be taught, right? So when we talk about this chapter, rest and motion, so first of all, the most important thing that we should be knowing is distance and displacement, right? And I hope that all of you are aware of these two terms. So distance we will be denoting by d, and displacement we will be denoting as s. Now the basic difference between distance and displacement is, first thing, that this distance term is a scalar quantity, whereas this displacement is what? It is a vector quantity. Means this term displacement has got both magnitude as well as a fixed direction. Yes, Tulsi Ram Reddy, yes, correct. So distance scalar, displacement is a vector, it has got direction also. So we will add one arrow over here also, so displacement being a vector. Now the next important thing that you should know, that whenever we have two different points, any two different points, there can be numerous paths that can take you from one point to other. So if you keep on traveling along different paths, the distance will be different, but the displacement between two set of points is always fixed. Means if you have a point A and if you have a point B, then there is only one displacement possible from A to B. That is what? The straight line joining the initial and final points. So what is actually displacement? It is the magnitude wise length of the direct line joining the initial and final point. So from where you are starting your motion and where you are ending your motion, if you join these two by a direct line, the length of the direct line gives you displacement, and it is always directed from the initial point to the final point. So S vector is directed from initial to final point always. So between two points there is only one value of displacement, magnitude, direction. If you see both, there is only one value of displacement between 2 points, whereas distance is total length of selected path. So if you select 2 points, yes, Ravi, yes, if you select total length of a selected path between 2 points, we call that as the distance. Now distance, remember that it is always positive. Distance is always positive, and if you talk of the distance traveled, then distance always keeps on increasing, it can never decrease. And distance traveled always increases. So if you have 2 different points, distance will be always positive, and as you talk of the distance traveled, it always increases, it can never decrease, Whereas when we talk about the displacement can be positive also, negative also, and it can be 0 also. It can be positive, negative or 0. When can it be 0? Yes, Ratna, yes, correct. Displacement can be positive, negative and 0. All the 3 cases can be possible. Now if the initial and final points are same, means you turn back in any type of path selected and you return back to the same point, so you say that your displacement is 0. Talking about positive and negative, when you are moving along a straight line, whenever we move along a straight line, we select one of the directions to be positive. Understood? When we move along a straight line, we select one of the direction to be positive. So till you are moving along that direction, your displacement will be positive. Now if you make a 180-degree turn and you start moving backwards, then we say that in the backward path displacement will be negative. Okay, again listen, if you are moving along a straight line, and you suppose select this distance or this direction to be positive, suppose I take this direction to be positive. So if I go from A to B and say this length is L, and what happens if we come back from B to a point C, let's take this as L dash. See clearly, I am taking example. If you are moving from A to B and then you are coming back to a point C, now what we will say, talking of the distance traveled from A to B to C, can anyone tell what is the distance I will travel from A to B to C? I am waiting for your answers. What will be the distance traveled? I have written D for distance, displacement I am denoting as S. Yes, L plus L dash. Why? Because distance never gets subtracted, it keeps on adding. So I will say it is AB plus BC. That is, we will say it is L plus L dash. Whereas if I say what is the displacement from A to B to C, if I talk of the displacement from A to B to C, yes, it will be L minus L dash. So this will be AB is in the positive direction. Suppose I have selected this direction as positive. So you are returning back in opposite direction. So AB minus BC, which is L minus L dash. Correct? So basic things about distance and displacement, I hope all of you got it. Yes. So we have L minus L dash as displacement, L plus L dash as distance. And you can also directly say what is the displacement. As I told, it is the shortest distance or the direct gap between A and C. If you see A and C points here, this is the displacement. We can call it as the magnitude of displacement. What is the magnitude of displacement? This is L, this is L dash. So you can see this gap is L minus L dash. We can say in this case also. So distance and displacement, one of them is always positive, one is positive, negative or can be 0 also. I hope this small example is clear to all of you. So we will move to the other terms also, and we will take other examples, important examples of distance and displacement. Okay. Now, taking examples of distance and displacement, very important ones. Suppose we move along a circular path. Suppose you move along a circular path. It's not necessary that you complete the circle, but you are moving along a circular path. Now, in this case, if this circular path is concerned and this being the center, suppose we start from a particular point, let's call this as A, and from here we start moving and we reach a point B. The radius of the path is R. So we have moved from A to B. Now what happens if suppose the angle that I have turned, suppose it is theta. Now what you need to do is, theta here I am taking in radians. Theta is in radians. I hope you all are aware of what is angle in degrees and what is the angle in radians. For example, 360 degree is equivalent to 2 pi radians. 360 degree is 2 pi radians, or we can say 180 degree is equivalent to pi radians. This you can remember as a conversion factor of degree to radians. Now what happens if I say 60 degree? So this will be equivalent to how much radians? If 60 degree we are taking, 180 degree is pi radian, so 60 degree will be how much? Pi by 3 radian. So any angle we can convert into radians, right? Now if we talk about A to B, when we move from A to B, what is the distance travelled? The distance travelled is nothing but the arc length. Distance travelled is arc length. Yes, I got correct answers from many, pi by 3. So distance travelled is the arc length, which we can denote as AB arc. And how to find the arc length? Very simple. When they ask you to find arc length, it is nothing but R radius multiplied by the angle turned. R theta. R into theta. Yes. R into theta, where you have to take theta in radians. So for example, if you make a complete circle, very simple, you know, if you make a very full circle, if you make a full circle, what is the angle you rotate? 360 degree. 360 degree is how much radian? 2 pi. So if I turn full circle, theta is 2 pi, what is the total distance? 2 pi into r. We know 2 pi r is the circumference of the circle. Correct? Now the main thing comes, displacement vector. Now if I say displacement vector, so what we have to do? We have to join them by a straight line, and this will be the direction of displacement. Means we will say displacement vector is AB vector. So the straight line which is joining A and B, this length will give you the magnitude of the displacement. Now what happens here? If I am asked what is the displacement, this is r, this is r, this is theta. Can any one of you tell that what is the displacement, what is the magnitude of displacement if the radius is r? Yes, correct. So I am getting correct answers. Fine, it is called, I am asking the magnitude of displacement, what will be the value? So it is a very simple result which we get by basic concept of trigonometry, which is 2r sin theta by 2. Yes, correct. So 2r, Subhashini correct, and Vikas also correct. 2r sin theta by 2 is the displacement. How we get it? Very simple, because if you take a triangle and both sides are equal, it is an isosceles triangle. So when we drop a perpendicular, suppose the total angle is theta, so what will be the half angle? It will be theta by 2. This will be also theta by 2. Now using trigonometry, if the hypotenuse is r, what is the perpendicular? Perpendicular will be r sine theta by 2. Similarly, this is the hypotenuse, this is the perpendicular. What we get? R sine theta by 2. So the total displacement from this point to this point is 2r sine theta by 2. Correct. So when we move along a circular path, arc, if you are considering an arc of a circle or the complete circle, yes, you can get the displacement. Okay. So no problem. Some students who are knowing this thing, very good. We will see questions there, we will see the use of this also, these all points which I am saying. So from my end, this is a brush up of the things which you already know and some things which you are about to know. Okay. So shall we proceed further? If you wish, you can take a screenshot of the same, and in any course of time you can take a screenshot of whatever is written on the board so that we can move forward. Okay, fine. Now next thing what we see is talking about velocity and speed. So velocity and speed, this particular thing, velocity is the rate of change, this is also a rate of change, but there is a difference in both. What is the difference between velocity and speed? This is again a vector quantity, this is a scalar quantity, and this is the rate of change of position. Mathly, I am sorry to say, but the definition that you have given is not actually correct. So just wait for some time, you will come to know the difference. Velocity, generally students think that it is displacement by time. It's not the correct thing. You all have studied the basics of calculus, wherein you have been told about how to find different terms in physics like velocity and say current and momentum and various things. So velocity is actually the rate of change of position with respect to time. Rate of change of position with respect to time, and the change in position is called displacement. So velocity is the rate of change of position with respect to time. And what is speed? Speed is the rate at which you are traveling distance with respect to time. So these two don't have any fixed formula. If I say, or if anyone says that velocity and speed have fixed formula, no, they don't have. These two are defined as rate of change of position with respect to time, and this is rate of change of distance travelled with respect to time. Both of these, since they are rates, they are of two types. One is called average velocity, which we denote as V average vector, and second we have what we call as instantaneous velocity, which is denoted as V vector. Whenever we are finding the rate of change of position at a particular instant, then we call that as instantaneous velocity, and for instantaneous velocity you have a formula. This is what you have studied. Velocity vector is written as ds by dt or dr by dt, where r denotes position vector. In vectors you have studied a bit about this. So rate of change of position or rate of displacement is called instantaneous velocity, and this is at a particular time instant t equals to t. This is at a particular time instant. Now when we talk about average velocity, Subhashini, you need to be listening a bit. What you have written, slightly it is different. Okay, so I am saying the actual definition. Velocity does not have any fixed formula until unless you are mentioning whether it is average velocity or instantaneous. When you are taking at an instant, we say it is obtained by differentiation. Whereas when we talk of average velocity, it is always calculated in a time interval, So how it is defined as? Average velocity is defined as the total displacement divided by time interval. So displacement upon time interval gives you average velocity. That is the difference between these two. Clear? Now what about speed? It is also a rate of change. So now this also is of two types. One we call as average speed and one we call as instantaneous speed. So suppose they ask you what is your speed at a particular instant. That is the instantaneous speed. How will you get that? Very simple. If you know the instantaneous velocity, just the magnitude of instantaneous velocity is always known as instantaneous speed. It is always known as instantaneous speed. Whenever we take the magnitude of instantaneous velocity, it becomes the instantaneous speed. Got it? Whereas average speed, if you compare from this side and that side, what we say, average speed is nothing but the total distance traveled divided by time interval. Whenever we divide distance by time, we call it as average speed, and whenever we take the magnitude of instantaneous velocity, we call it as instantaneous speed. Understood? So just focus on these terms because this will be now used in what we call as uniform motion. So average velocity, average speed, instantaneous velocity, instantaneous speed. This much is more than sufficient to know about velocity and speed. Just keep this in mind. You won't have any problems related to this. Is it clear to all of you? And I would request some of the students who are more interested in discussing other things which are not related to the chapter being going on. So kindly you can stop your comments over here. Please focus in the class. You can do that later on. Okay. So velocity and speed we understood. Now next we come to what is called as uniform motion. Now when we say uniform motion, this is the most basic form of motion, which is also known as undisturbed motion. Means there is no external intervention, there is no external force which is disturbing the motion. Now if there is no external force disturbing the motion, we can simply say that acceleration is zero. So uniform motion simply means that acceleration is how much? Zero. Yes, acceleration zero, which we know acceleration is also known as the rate of change of velocity with respect to time. Acceleration is the rate of change of velocity with respect to time. So we can clearly say that velocity remains constant throughout. So whenever velocity is constant throughout, we call the type of motion as uniform. Okay. Now what is the direction of velocity? Always remember, velocity gives you the direction along which a body is moving at a particular instant. At a particular instant, whichever direction you are following, that is the direction of velocity. So if your velocity is constant, that means what? You are not changing your direction. If you are not changing your direction, then what can we say? What type of path is possible in uniform motion? Kindly comment everyone. what type of path will be possible in case of uniform motion. As I said, velocity constant means its magnitude and direction both are not changing. So since the direction of motion is not changing, that means what type of path will you follow during uniform motion? Yes, correct. One student, Venkata Shivakumari, straight line, correct. All subject corner, I don't know what name you have given to yourself, you are wrong. It's not circle, it is a straight line. Yes. So it is possible only along a straight line path. The path is a straight line. Now one thing more. Whenever you are moving with constant velocity, what we can say, if I take a number, for example 3, okay, and I ask you to take the average of 3 10 times, what will be your answer? Quickly reply. Suppose I have placed 10 threes in a line, number 3 10 times I have written, and I ask you what is its average. What is its average? What will be your answer? Yes, correct. It will be 3 only. You take 3000 times. What will be the average? It will still be 3. That means when we have a constant, then its instantaneous value and its average value both are same. So this is another important thing, that whenever we have a uniform motion, always remember that average velocity is equal to instantaneous velocity. Means at every instant the velocity will be same, and that will be same as the average velocity, which you can write as displacement by time. Displacement by time. Average and instantaneous both can be written as displacement by time. Clear? Or you can write displacement is equals to average velocity or velocity into time. Both are same. This is why I just told, what did I say? Again repeating, whenever something is constant, suppose I ask you to put a number, say 5. 5 times or 10 times you keep in a line and you pick any number, what will you get? 5 or 6? You will get 5. Take the average of all. 5, add it 10 times and divide. So what you will get? 5 only. So when I am saying anything is constant, remember its average value and instantaneous values both are same. So you get displacement is equals to velocity into time. Velocity is equals to displacement by time. Clear? Now, since we know velocity of magnitude is the speed, so this value speed can be also written as distance by time. Speed is distance by time. Why? Because average velocity is equal to instantaneous velocity, and instantaneous velocity magnitude is what? The instantaneous speed. So speed is equals to distance by time, velocity is equals to displacement by time. You can directly use for uniform motion. So for uniform motion, this thing should be remembered. Velocity is equals to displacement by time and speed is equals to distance by time. This is a very important formula which you are going to use. I hope this is clear to all of you. So whenever we have this type of motion in any segment, if you see that the velocity is remaining constant, if velocity is remaining constant, then you can use directly this formula. Velocity is equals to displacement by time, speed is equals to distance by time. Okay. Now the most important part of this comes, where you cover journey in parts. Whenever we cover journey in parts, whenever you break a journey into different parts, so remember, if they ask you average velocity, so what you use? You will use the formula still valid, total displacement by total time. Whenever they ask you average speed, you will use total distance by total time. Total distance by total time. Example, if suppose they say that I am moving from a point A to a point B. Yes, correct. I am moving from a point A to point B and I cover this journey in 3 parts, A, C, C, D and B. Now suppose from A to C I am moving with a speed of V1. From C to D I am moving at a speed V2 and here I am moving at a speed V3. And suppose here I take a time T1, here I take a time T2, here I take a time T3. So if they ask me what is my average speed while I go from A to B. If they ask me what is my average speed when I go from A to B, what should be my answer? I will say total distance. See here, total distance. What is the total distance? It is AC plus CD plus DB and the total time you can see is T1 plus T2 plus T3. Got it? Now, what happens over here is sometimes they will give you the distances, sometimes they will give you speed and times. So if here you see the distance is not given, what formula can we use? Since we know that V is equals to distance by time, so I can write distance is equals to speed into time also. I can write distance is equals to speed into time. So AC, what is your speed? V1. What is the time? T1. So AC I can write or not? V1 T1. CD, speed is V2, time is T2. What can I write? V2 T2. What is DB? DB is V3 T3. V1 T1, V2 T2, V3 T3 and divided by T1 plus T2 plus T3. T1 plus T2 plus T3. So this is my average speed whenever we are considering a journey broken into 3 parts and the speeds and times are given. So what you need to, yes, correct, Ratna, correct. Whenever we are covering a journey in parts, just remember how to find the average speed. Clear? So this is average speed. Now from here we get one very important result which I would like to tell you and you can remember it very well. Suppose all intervals of time are same. If you are covering a journey, listen carefully, if you are covering a journey in different parts, and if time intervals are same for all, that is T1, T2, T3, all are same. Now can you say what will be the average speed formula we will get? If you put T1, T2, T3 all as same as T, what will you get? You will simply get V1T, V2T, V3T divided by 3T. So see, yes, correct, very good. It is V1 plus V2 plus V3 by 3. Means it is the average of all the speeds. Listen carefully. If you take all the intervals of time of a journey to be same, then the average speed is equal to the average of all the speeds. If you take 2 equal time intervals, average speed will be V1 plus V2 by 2. If you take 3 time intervals, average speed will be V1 plus V2 plus V3 by 3. If you take 4 equal time intervals, average speed will be V1 plus V2 plus V3 plus V4 by 4. So it is the average of all the speeds. So this is a very important point. Kindly remember this whenever we have equal time intervals. If a journey is being covered in equal time intervals, this is what we have to remember. Clear? Yes, correct. Balu, I think you have made a small mistake. In the denominator T won't come, just it is V1 plus V2 plus V3 by 3 because t and here 3t will cancel, you will get this. Okay. So this is the concept that we are going to use in average speed, average velocity. Instead of distance you will take displacement, that's it. Now we will try to use these in forms of question. Clear? Okay. Let's come to some questions. Now the first question that you can see over here, we have been given a case where a person is jogging along a circular track, but did he cover the entire circle? The answer is no. He did not cover the entire circle. Instead he made an arc of 120 degree. So if he is making an arc of 120 degree, what is the ratio of magnitude of his displacement to his distance covered? Now I told that whenever we have a circular arc, this is your displacement, this is your distance. So distance is r theta and displacement is 2r sine theta by 2. Correct? Now what is theta? Theta is given in the question as 120 degree. I told convert it in radians. So if I convert this in radian, so it will become how much? Will it become 2 pi by 3? So in radians it becomes 2 pi by 3. Now what is the value of distance? R into theta. So this becomes how much? 2 pi r by 3. I hope you all agree to this. 2 pi r by 3. Now comes the displacement. 2r sine theta by 2. Displacement is 2r sine theta by 2. What is theta? Theta over here is 120 degree. So when you put the value 120 by 2 is 60 degree. Sine 60 we know is how much? Root 3 by 2. So 2r into root 3 by 2 is how much? R root 3. So from here R root 3 is the displacement and distance is 2 pi r by 3. Now yes, correct. Now what they are saying, the ratio of magnitude of displacement divided by the distance covered. So you can directly write now displacement is r root 3 and this one is 2 pi r by 3. So r cancels, we get 3 root 3 by 2 pi, which is yes, correct, which is which option? Option A. So the correct option over here, I got some of the answers as B also. B is not the correct one. Actually the correct one is answer. Correct one is option A. Okay. Yes, Kritika, Himanya, yes, correct. Sushant, you need to be a bit more careful and don't just give random guesses, because you can see that the answer is coming as 3 root 3 by 2 pi. Okay. So we are moving on to the next question. I hope this is clear to all of you. Okay. So just give a reply yes so that we can move to the next question. You can take a screenshot in meanwhile. Okay. Now next question comes. A man walks for some time t with velocity v due east. Now when we take directions, we know that this side, if we are taking as east, this is north, this is west and this is south. So where is the man moving? Due east. So he starts from here, suppose this point is A and he goes to a point B due east. What velocity v? What time t? So if he moves with velocity v, and for time t. So can I find this distance? I can say it is directly Vt. Now after this, then he walks for same time t with velocity v due north. Now he has shifted himself and going north. Like this. He comes at a point C. Again he is moving at velocity v and time is t. So I can say this also will be Vt. Now read what they are asking in the question. They are asking the average velocity. What formula I told for average velocity? Remember, it's not average speed dear. Average velocity is total displacement by total time. Is it so? Total displacement by total time. So what is your displacement? Displacement is the shortest distance that you find by joining the initial and final points. So this one will be your displacement. This is the displacement. So when it is displacement, what is the value of displacement? This is Vt, this is Vt. So this displacement will be the hypotenuse. Can I write it is Vt root 2? It is Vt root 2 under root of a square plus a square is root 2a. So Vt root 2, and what is the total time you have taken? The total time that you have taken is t plus t. You have taken a total time of 2t. You have taken a total time of 2t. So what is my final answer? Tt cancels. 2 by root 2 becomes v by root 2. Yes, correct. Option 4 is the correct option. So we first moved horizontally along the east and then we made a 90-degree turn and we went towards north. So our answer will be v by root 2. Is it correct? Yes. And I am getting the same reply from many of you. Okay, I hope you understood this. Let me get a quick reply if you have completed so that we can take one more question. Okay. Now next question, as you can see on your screen, we have a body which is covering a journey in parts, and you can see how many parts are there. It is covering a journey in 3 parts. 1/3 of the distance with a velocity v1, second 1/3 of the distance with a velocity v2, and last 1/3 of the distance with a velocity v3. What is the average velocity? Now see, many of you quickly give your answer as v1 plus v2 plus v3 by 3, right? But think first, are the 3 distances covered in equal time intervals or equal distances? Reply fast. Is it covered in equal time intervals or distances? It is distance, not time. So you cannot directly use v1 plus v2 plus v3 by 3. Might be coincidence that you get same answer in some cases, but don't apply that. It is distance. So always go by the method which I told. Very simple. You will break the journey into parts, and here they are saying it is covering 1/3, 1/3, 1/3, means all the distances are equal. So if all the distances are equal, if I take this distance as x, can I say this will be also x, this will be also x? Because 1/3 means all the 3 parts are equal. So x, x, x. Now here you are moving at what speed? Here you are moving at v1, here you are moving at v2, here you are moving at v3. Understood? So final thing, when we see average speed, we say total distance by total time. So we will write here, what is the total distance? You had assumed x, so you will write the total distance as 3x. 3x. Now, have they given the time? Answer is no. If they haven't given the time, how to find the time? Very simple. We can use time as equals to distance by speed. So I can write x by v1. I can take this time as x by v2. I can take this time as x by v3, or not. Distance and speeds are given. So just put the value. What is the time? First time x by v1, second x by v2, third x by v3. So from here all the x will cancel, and if you take the LCM v1, v2, v3, it goes up. So we get 3 v1, v2, v3 by, if you take the LCM below properly, you can check v2, v3, v1, v3, v1, v2. So what will be the answer for this question? If you check, it is the second option. Yes, some options given by you are correct. So we took a few questions here. In next class, before starting uniformly accelerated motion, I'll take some other important examples, quick examples of uniform motion, and then we will also see the concepts of uniformly accelerated motion. I hope you understood this thing. You can take a screenshot of the same. Okay. So thanks to all of you.
Yes, good morning everyone. I hope it is visible and audible to you, right? Good morning. Is it audible and visible to you? Good morning, good morning. Right. Okay, it's audible and visible, right? Okay, bacha. So in yesterday class, we did alkanes, right? We started with the two major rules of nomenclature. And what are the rules? The first rule was how to find the parent chain. And next rule was how to do the numbering, right? So how to find the parent chain, and after finding the parent chain, how to do its numbering, right? Clear, bacha? Okay, so we did our topic yesterday. So we are doing some questions on alkane now. Okay, so everyone will answer carefully and attend the class with concentration, right, bacha? Yes, Rockstar. Okay. We have easy questions. We will revise our rules once again, right? Clear? Okay, so please try this one first. Yes, everyone. Is it visible to you? Is it visible to you? I hope it is visible, right? Okay, so yes, bacha. First question is, write the IUPAC name of this given compound. So first of all, find, okay, I'm writing here also little bit. This is our compound. So we want to find its IUPAC name. Very good. So we write. So first of all, we will do one thing. We will find the parent chain. This is our parent chain, right? And in that, I will start numbering from where? I will start numbering from here, right? because locant is near to this end. So I will say 1, 2, 3 and 4. So at 2 location what we have? At 2 location we have methyl, right? So first of all our substituent 2-methyl butane. 2-methyl butane. Clear? Now tell me one thing. When I am saying 2-methyl, it is what? It is your what part, bacha? It is your secondary prefix, right? What is but here? But is word root, and what is n here? N is your primary suffix. N is primary suffix. Very good. Right. So what? Which answer is right? 2-methyl butane. Third answer. Very good. Most of you did right. Good. Next thing. Tell me this one. Fast. Yes, everyone. Give me the correct answer for this question. Right? So, first of all, find the main chain. Which one is our parent chain? First, find the parent chain. What is parent chain? If you look at this, I have how many carbon? 1 carbon, 2 carbon, 3, 4, 5, 6, 7. If I start from this end, 1, 2, 3, I am getting my first locant at third location, and from this end 1, 2, 3. So both ends are same. From both ends my locant is coming at 3 position, right? And locant is also same, right? Okay, we'll check which what is the right answer. So 1, 2, 3, 4, 5, 6, 7. So I have methyl group at third position and which one? Fifth one, right? So I will go, but it will be 3, 5 dimethyl. And how many carbons are there? Heptane. 3, 5 dimethyl heptane. Which option is there? 3, 5 dimethyl heptane, right? Third is the right answer. Very good. Most of students gave third answer. Some are saying first. So be careful, beta. Some are saying first. If I will go here, my chain is long, na? Some students are doing mistake. They are taking this as main chain. 1, 2, 3, 4, 5, 6. No. This is main chain because it contains more number of carbons. Be careful about it. Very right answer. Third is right answer. Okay, fine. I hope we are clear. Now, okay, next thing. Tell me please. We have to give the IUPAC name of this compound. They have given the structure in form of condensed form. It is in condensed form. First make it in bond line representation, then give the answer. Okay? What that means? See carefully. I am writing here. This C is having hydrogen. This C beta, this one, this carbon. And it is having here carbon like CH3, carbon, CH3, and again I have CH here, and this is what? CH3, CH3. Now please give the answer. Carefully give the answer. Don't make mistake. CH having CH3 twice, again CH having CH3 twice. So I converted the condensed representation into you can say complete representation formula. Okay, we did this topic, right? So please now check it. Right, fast. Right. So from here, if I say beta, what is the main chain? This is our main chain. I can see this is our main chain, right? This is our main chain with 4 carbons. We have our main chain with 4 carbons, right? Very good. So I will say this is my first carbon, this is my second carbon, third carbon, 4 carbon. What is coming then? What is coming? It is coming 2, 3 dimethyl butane. 2, 3 dimethyl butane, right? Second answer, right? 2, 3 dimethyl butane. Clear beta? 1, 2, 3. Okay, 1, 2, 3. At 2 I have methyl, at 3 I have methyl, so 2, 3 dimethyl butane, right? Very good. Great. Good. Okay, bacha. Next one. Look at this. Carefully give the answer. It's a very important question. Carefully give the answer this time. Main chain, if you see beta, main chain is very clear, na? Main chain is very clear. This is our main chain. This is our main chain, but main task is from which end I should start numbering. From which end I should start numbering? Yes, bacha. From which end I should start numbering? Tell me first of all, left or right? I should start numbering from left or right? Fast. Left or right? Yes, better right. Look at this Y. It's the first carbon, second carbon, third, 4, 5, 6, 7. Why we are starting from right? Because from right end, our first substituent coming at which location? First location. Lowest locant rule. Lowest locant rule. From this end, my first substituent coming at which location? 2. So I will start from that end from which I am getting my first locant at lowest position. I am getting from here what? 1 position, from here 1, 2. So I will start from here, right? Very good. Now I have 3 substituents here, right? What is it? Bromo, chloro, methyl. Now we have to write these substituents in alphabetical order, right? So beta, first bromo, because B is coming first, na? Bromo, then 6 chloro, right? And then what is coming next one? 5 methyl. 5 methyl, and how many carbons are there? 7 carbons, so heptane. Now we can check which one is the given this one. 1 bromo, 6 chloro, 5 methyl, heptane. Fourth answer, very good. Most of you are doing right. Okay, so it is a very important question that you should start from here using the lowest locant rule. Very careful. Okay, bacha, fine. On this basis, I am giving you one more question. So please answer me. I am writing here only. Give me answer for this question. I am taking C here, C, right? And here I am taking carbon, and here I have carbon. So please give me answer for this question. First find the main chain and then do numbering properly. It's very important for us. Fast, give me name for this question. Write by yourself. I should start from which end? In this question, if I take beta, I should start from which end? Carefully give me answer. From which end I should start? Right. You are saying from right end. Why from right end? Because from right end, our first locant is coming at low position. From this end, 1, 2. From this end, 1, 2, 3. So we'll start from here. 1, 2, 3, 4, 5, 6, 7. Very good. Joshua give the answer, but check carefully once. What is it? Yes, I will say 2, 5, 5, trimethyl. 2, 5, 5, trimethyl. Na? 3 substituents are there. Methyl. Trimethyl, heptane. Fine. Yes, 2, 5, 5, trimethyl heptane. Very good. I hope we are clear. Done, bacha? Okay then, next one. Right. Next one is the formula. They are asking formula for the 1,2-dichlorotetrafluoroethane. 1,2-dichlorotetrafluoroethane. So please give me answer. Which one is right here? First of all, we start from the word root, right? What is the word root here? Ethane, right? Eth means how many carbons? 2 carbons. Ethane means 2 carbon, right? Now, ane means single bonds only, it's also fine. I am having 1,2-dichloro. So at 1 carbon, I have chloro. Second also what? Chloro, right? And next thing they are saying, tetrafluoro. So 4 fluorines, 4 fluorines. So but definitely to have 4 fluorines, I have to keep 2 here, na? Right? They are not giving the numbering of fluorine because there is no other chance than this. There is no numbering given to fluorines because there is no other chance possible. Because if there are 4 fluorines, definitely 2 will come on this carbon, 2 will come on this carbon. Nothing else option is possible. That's why even they are not mentioning, right? So you are saying very right, third answer. Third answer is very right. Yes, beta? Fine. I am giving you one more question like this. I will give you name, you write the structure. Fine? Please try this one. Same way I am giving. I am saying 3 bromo. It's 3 bromo. And you can say 2 fluoro pentane. Is better try in your notebook. 3 bromo 2 chloro, sorry, 3 bromo 2 fluoro pentane. Try to draw this by yourself. Is better? Fast. You can see here, I will start from word root, pent and then ane. Pent, ane means bacha first draw the 5 carbons. Pent, ane, right? Single bonds, right bacha? And now they are saying 3 bromo. So if I am saying it is 1, it is 2, it is 3, it is 4, it is 5. They are saying 3 bromo. So 3 bromo here, it's bromo here, and what we have? 2 fluoro. So 2 fluoro. Okay, 3 bromo, 2 fluoro, pentane. Very good. Right. I hope we are clear here. Right? Why I am writing bromo first? Because B alphabetically is preferable than F. Right? Fine. Very good, Rockstar, Ratna, Madhu. Okay, bache. Right. Fine. I am going to the next one. Okay, please tell me. Same type question, please answer. Same type of question, please answer. What they are saying? They are saying nonane. None means beta how many carbons? 9 carbons. Ane means what? Ane means it is saturated, means single bond, na? So first of all draw 9 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Check. Fine. Now come to the point. They are saying 6 ethyl. 6 ethyl beta. 6 means first of all do numbering. I am giving 1, 2, 3, 4, 5, 6, 7, 8, 9. They are saying 6 ethyl. Okay, I am here. I am putting ethyl, C2H5, 6 ethyl, right? The next one they are saying 2, 3, 5 trimethyl. 2, 3, 5 trimethyl. I'm saying once again 2, 3, 5 trimethyl. And what is on 6? Ethyl. What is on 6? Ethyl. Okay. You're getting first answer? Is it first structure? Is everyone first structure? We can check, right? Okay, if we check, bache, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Now, what is substrate, beta? What is substrate here? At 2, methyl. At 3 also what we have? Methyl. At 5 what we have? Methyl. And at 6 what we have? Ethyl. Very good. First is the right answer. Right? I hope we are clear now. Okay, fine. Rockstar saying third. Why third? First is right answer. Fine. Third you are saying I can check once if you are saying because you are doing well. What they are saying, you can check. First of all, find the longest chain. Where is longest chain? Okay, we have here 1, 2, 3, 4, 5, 6, 7, 8. Or 1, 2, 3, 4. Sorry, I missed one here, na? 1, 2, 3, 4, 5, 6, 7, 8, 9. Very good. Now we will check this. The substrand one. Where is substrand? 2, 3, 4, 5. Beta, its name, if you write, na, its name is coming what? Its name is coming 1, 2, 3, 4, 5. Its name is what? 5-propyl. It is 5-propyl, right? It is 5-propyl. What is next one? 2, 3, 4. Trimethylnonane. Okay? Okay, bacha? Okay, rockstar. So this way you can write the name, reverse way you can go. Okay, so you can see different name is coming. Fine? Done. Okay, fine. Next question, bacha. Fine. A student named a certain compound as this one, but it is actually incorrect. First, by the structure, write by the given name, write structure, and then check is it right or wrong. That's doing some mistake. Is everyone? If I write this here, butane, they're saying butane, right? And now they're saying add 2 and 3, add 2, 1, 2, 3, 4, add 2 and 3, they are keeping it of what? They're saying ethyl, I will say ethyl, sorry, it's ethyl, ethyl, here ethyl, and here also what? Ethyl. Is it the right name for this structure? Is it the right name for this structure? If it is not, then give me right answer. In this structure, what should be the main chain or parent chain? If you see carefully, in this main chain like this, na, long chain I will take. This is my long chain. Fine. And then you see, if I am calling this first carbon, second carbon, third carbon, 4 carbon, 5 carbon, 6 carbon, right? So I will have 3, 4 dimethyl. It is 3, 4 dimethyl hexane. 3, 4 dimethyl hexane, right? So which option is right? Okay, Rajani, Swati, Sairaj, very good. Jeevan, everyone is doing great. Very good, very good. Okay, so your answer is second one, right one, right. I hope we are clear. Okay, bacha. So now we will do some questions on basis of alkene alkyne. First of all, we will understand I will give examples, then we will do some question. Okay. So let us start. Alkene alkyne name. Okay. First I am taking alkene. Same rules, almost beta all are same rules, nothing else. Just in case of alkenes, but we had to use ene. Okay, we have to give ene. And you know, pi bond if present, so it should be in your main chain if function groups are not disturbing it, right? Okay, fine. Now I am giving example, so please try to write the name. See here, see beta. What is the name for this? Next one is C, double bond C here. This one, okay? And one more I am taking here. C, carbon, double bond, bromine. Okay, fine. Yes, everyone. What is our main chain? What is our main chain? There is only one chain present, so nothing confusion comes. I should start numbering from that end, which is near the pi bond. 1, 2, 3, 4. What is coming? But 1 ene, right? Do not forget to give number to the pi bond. Don't forget to give number to the pi bond, right? Clear? Okay, but 1 ene, right? Okay, Swati, Rockstar, Sairaj, yes, you're doing good. You're doing very well. Okay, next one. Definitely our main chain is this one, huh? This is our main chain. Okay, this is our main chain. So first main chain selected. Now I should start my numbering of chain from this end or this end. Definitely from pi bone I will start. We will start from pi bone, na? 1, 2, 3, 4, 5. I will start from that end which is having pi bond. Clear? Very good. Fine, bacha, fine. Okay, so I will say 3 methyl. It is 3 methyl for substituent. Then pent. What location is there? Pent 1 ene. Don't forget to give numbering to the ene. 3 methyl pent 1 ene. Very good. Very good. Right. Okay, fine. Now here in third case, tell me, during the numbering, locant rule is more important, lowest locant rule is more important, or pi bond is more important? Please tell me first of all. What is more important? Lowest locant rule is more important or pi bond? Yes, everyone, tell me. What is more important? Out of substituent or pi bond, what is more important? Pi bond is more important. Remember, locant is not important, pi bond is important. Very good. So I should start numbering from which end? Left and right hand. I should start numbering from which end? Left hand or right hand, beta? I will start from here, right? 1, 2, 3, 4, 5, 6. Right? I will not start from here because pi bond is more important for me. I have given you rule for numbering, right? So from here what is coming? I will say 6 bromo. 6 bromo. How many carbons total? 6 carbons. Hex. And our ene is at which carbon? 2 carbon. Hex 2 ene. Right? 6 bromo. Hex 2 ene. Very good. Right. Is it a Fikshana, Sipana? Very right answer. Very good. Okay, same way. Just give me the answer now. Same way you have to give answer. Now tell me. Tell me, Bacha, now. Think carefully, give me answer. First of all, select the parent chain. From which end I should start? From which end I should start? Fast. I should start from left hand or right hand, beta? I should start from which end? Left or right? Carefully give the answer. Very good. Someone is asking, sir, BR is a functional group. No, but BR is not a functional group. It is just a substituent. Okay. So definitely, as we have done just now, for us, pi bond is more important. For pi bond, I am getting 1, 2, 3 from this side, 1, 2, 3 from this side. From both sides, I am getting same position, 3. Right? But from this end, I can get bromine also at less position. Nah? So I will start from here. 1, 2, 3. Pi bond is coming at same location from both ends. From this end, what benefit is there? That bromine is coming at low position. Pi bond happy. After keeping pi bond happy, then I am keeping bromine also happy. Right? If possible is there. If possibility is there, right? So I will say 1 bromo. Very right. 1 bromo. 1 bromo. Hex 3 ene. Very good. Right. Right, Tikshana. Very good. Okay, fine. Now next one. If I will take 2 pi bond, then what will happen? C. Here we have. I have here pi bond and also 1 pi bond here, right? Only one substituent. there are 2 pi bonds. So that's why you will write diene. You will write diene. Okay, bacha, diene you will write. Okay. So see, bache, there is only one chain, so no doubt will come in that. There is no doubt because there is one chain only. In selecting parent chain, very simple. Numbering also, it is easy to go from here. 1, 2, 3, 4, 5. Right. So what is the name for when there are 2 pi bonds? I will not say just pent. I will say penta. When there are 2 pi bonds, just add A also. Penta, hexa, buta, right? So I am using penta 1, 3, diene. Why I am using di? Because there are 2 pi bonds. Next thing is I am using A also, penta. Okay, be careful about this A word, right? This A they will add, penta. Instead of pent, just they are saying penta, right? Penta. And di also coming, right? This is a little new for us, right? Okay, now next thing is this one. Carefully read the answer. Think about it. Main thing is I should take which one as my main chain? Straight chain is my main chain, or I should take the longer chain as my main chain? Which chain I should take as my main chain? Straight chain or this one? Straight. Because straight contains more pi bonds. When you select the parent chain, what is more important? In selecting the parent chain, pi bonds are more important. I should include more pi bonds in my chain. Instead of taking a long chain, I should take more pi bonds in my chain. Remember that point? Okay? Yes. Because it contains pi bond. I will take straight one. Because it contains my pi bond. Okay? From which end I should start numbering? From this end or this end? Both are same only. No difference. Okay? 1, 2, 3, 4, 5. Or 1, 2, 3. So same thing. Now this is our locand. Now this is our locand. Substance, sorry. What we call this 3? Its name is 3-butyl. It is 3-butyl. Substance, na? In substance, we use "-ile" word. 3-butyl penta. Again, same thing. 3-butyl penta 1,3-diene. Right? 3-butyl penta 1,3-diene. I hope we are clear here. No, beta, Mallikarjun. Carbons are not important. What is more important? Pi bond is important. I gave you a sequence, remember? I have given you a sequence if you check your notes in previous class. The most important thing is function group. Your chain must include function group, the main function group. Second thing is number of pi bonds. Your chain must include more pi bonds. Third thing is length of chain. Length of chain is less important than pi bonds or function group priority, right? Right, bacha? Clear? 1, 2, 3, 4, 5. At 3 I have what? Butyl. 3-butyl penta 1,3-diene. Yes, everyone? I hope you are clear. Someone is asking here, sir, why not 4? One more thing, you can listen very carefully, everyone. You will take the first carbon which is having pi bond, like I am taking here 1, 2, 3. Third carbon I will say pi bond. If you are coming from here 1, 4, 1, 2, 3, 4, 5. So 3 I will count. I will say 1,3-diene. Right? Butyl means 4 carbon here, right? Downside you are saying. Oh, fine. Right. Here 4 I will take. Here 4 I will take. Right. Because 1, 2, 3, 4. Right, it is right. I will take 1, 4. 1, 4-diene. Numbering is enough. 4 I am coming. Right. Because 4th is present where? On the next pi bond is where? On 4th carbon. Right? Very good. Clear, bacha. Fine. Very good. Because it is at here, first carbon, second, third is having what? Substrate, and fourth have what? Pi bond. Clear, bacha? Right? Okay, fine. Now come to the next point. Now we are taking alkynes. Okay, beta? We will take alkyne. Then mixed question of alkene and alkyne. Okay, fine, everyone? Okay. Next one is alkyne. We are taking, bacha. For alkyne, we will use which one? Ine. Instead of ane, I will use ine here, right? Okay? Fine, fine. Now, please, first simplest one, answer this question. First question. Second. Okay, third one. Fast, fast. Okay, fast. Yes, everyone. Ine, just one new thing. In case of triple bond, use the word ine. Y-N-E, ine. Nothing new. Sir, pass the water bottle. Fine. Clear, bacha? So, yes, first one if we check, I'll say there is only one chain, straight chain, there is no substrate. 1, 2, 3, 4, 5, 6. Simple one. We'll say hex 2 ine. Hex 2 ine. Very good. It's hex 2 ine. Fine. Okay. Next one, bacha. Next one is here. I should start from this end or this end. Pi bond is more important. I will start from here. 1, 2, 3, 4, 5, 6. Because pi bond is more important than what? Any substrate here. Okay. Now, what is the name of this compound? 5-bromo. Its name is 5-bromo. Right? Hex 2-ine. 5-bromo, 1, 2, 3, 4, 5, 5-bromo, hex 2-ine, hex 2-ine. Okay, bacha? Good. Next one, if you check, bacha, both have pi bonds, so you can start from here. 1, 2, 3, 4, 5, 6, right? 6, so you'll say hexa what? 1, 5, di-ine. Hexa 1, 5 di-ine. Yes, Chakri beta. Chakri di-ine. You are saying ine, okay? But very good. Most of you are doing right. Is it after some days only? Only 1 week or max to max 8-9 days, college will open. And we are waiting for you, okay? To have live interaction, okay? Means offline interaction I'm talking about, right? Okay. So after NEET exam, as soon as possible, you will come to college, right? Okay, fine. Next I am asking here one more question, fourth one. Please answer this. Answer this. Very easy question, don't do mistake. Take the chain properly. Take the chain properly. Take the chain properly. Yes, everyone. Don't make mistake. This is not chain end. You can tell like this, na? Don't think it is what? It is side chain. It can be part of what? Main chain only. Just I am writing this way. It will not change the name. I write upside, downside. It will not change the name, right? 1, 2, 3, 4, 5, 6, 7, 8. Very good. What is coming? Oct. Oct-2-ine. It is oct-2-ine. Fine, fine. Okay. Okay, now I am taking the questions in which alkene means ene and ine both are present. So you have to be very particular about this question, okay? Don't do mistake. Now, fifth one I am taking here. Look at this. Okay, bacha. Now in this, double bond is present as well as triple bond. So it is in also, in also. Okay, follow the lowest locant rule and give lowest position to the first pi bond, right? Like here, if I start from here, I am getting 1, 2, 3, 4, 5, 6. From this end, I am getting 1 location and 5. But from this end, I am getting 2. So by the lowest locant rule, I will choose this one as 1, right? Clear? Okay, fine. What is it? Hex. We have hex here, hex 1 in. And what beta? 4 in. Remember, in will be written first, in later, alphabetically. In, then in, always. Whatever is numbering, in will come first, then what will come? In. In. Hex 1 in, 4 in. Very good. Fine. Hex 1 in, 4 in. Fine. Good. Very good. Okay, bacha. Next one is, now, carefully give the answer, don't make mistake. Now, from which end I should start numbering? Carefully give the answer. No, Mallikarjun, triple bond is not preferred over double bond. They have equal priority. Double, triple have equal priority, but in some cases, double will be preferred. I will show you. Double and triple have equal priority, no issue. Position must come lowest. From which end I should start? Yes, I should start from which end? Right end. I am getting 1, na? 1, 2, 3, 4, 5, 6. Right end. If I start from here, look at this. If I start beta from here, what I will say? 1, 2, 3, 4, 5, 6. Then I am getting at which location? 2, na? Our first position, our first locant, or you can say pi bond, should come at lowest position. From this end, I am getting at 1. From this end, I am getting 1, 2. So what is more important? This one is more important, right? This time, fine. So, what is coming name for this? It's coming hex. Hex 4 in 1 in. Hex 4 in 1 in. Very good. Great. You're doing good. Hex 4 in 1 in. Very good. Now one twist is coming. Very carefully give the answer. One twist is coming. Okay? I hope we are clear now. Now, in this case, what answer you'll give? Think carefully. I have here double bond and here I have triple bond. Now, from both the positions, from this position, I am getting 1 to double bond, and here I am getting triple to double, triple getting which position? 1. When rows are getting tied, I am getting 1 position from here and also 1 from here. Then what will do? Then pi bond is more preferred over triple bond. Remember, double bond is more preferred over triple bond. In such case, double bond is more preferred. I will say 1, 2, 3, 4, 5, 6. Normally though, alkene alkynes are equally preferable. Double bond and triple bond are equally preferable. But when all rules are getting tied, in such situation, you prefer pi bond. I am saying once again, you prefer pi bond or double bond only when all other rules are what? Tied. Right? So, name will be hex. It's hex beta. Hex 1 in 5 in. It is very important example. Please star mark this. Star mark. Because here most of students make mistake. Here, most of students make mistakes, so please be carefully. Yes, both are at ends. So no rule is helping you. You see, beta, you see, if I'm saying once again, if I go from here, I'm getting which location? I'm getting like which one? Look, 1, 2, 3, 4, 5, 6. This end I'm getting position 1, 5. From this end also what? 1, 5. From both end I'm getting position 1, 5, 1, 5. So lowest position rule is not helping us. Lowest position rule is not helping us. That's why in such cases double bond is preferred over triple bond. I hope we are clear. I hope we are clear now. In such case double is preferred over triple when both are present at ends, or you can say when every rule is tie. Are we clear? Are we sure? Okay, bacha? So please star mark this. Star mark this question. Clear? Only and only double will be preferred when all other rule are at tie. They are not deciding. So what I will do? Then I will take pi bond over triple bond. Okay, bacha, Ratna bache. Thank you very much. Okay. Okay, bacha. Bye then. Tomorrow we will see question from alkene alkynes. Lot of more questions to clarify these concepts. Okay, bacha. This is it for today. Tomorrow I will discuss this point once again, just to remind you. Okay, don't worry about it. And I will give one more question like this. Okay, bache. Bye then. See you. I hope you are getting benefit by these classes. Okay, see you. And we are waiting for you in our campus, right? Okay, bye, bacha. See you.
Yeah, good morning, students. How are you? Hello, students. How are you? Respond. Good morning. Good morning, all of you. Chatting with your friends. Good morning. Yeah, good morning, guys. Good morning, girls. Good morning. Very, very good morning. Yeah. I hope you had a nice Sunday yesterday. Enjoyed a lot. Okay, good morning. Good morning. Did you read? Yeah, I'm good. I'm good, Sairaj. I'm fine. I'm fine. I am fine, Charita. Very good. I'm very fine. Yes. Yes, very good. Very good. I'm good. I'm good. I hope all of you are staying at home, right? Yeah. Very good. Take care of yourself. I hope you read Botany before. Whatever the previous class I have completed, did you read that? Yes. Very good. Very good. Keep it up. Keep it up. Good. I'll ask just two questions and then we'll proceed to the actual topic of today's, that is cell organelles. Yeah, I'm good, Amma. I'm good. I'm good. Are you ready to answer? Give a thumbs up if you want to answer the questions. Yeah, would you like to answer the questions? Okay, yes. Very good, very good, very good. So let me ask you simple two questions. Yeah, very good, very good. Previous class you have learnt cell wall and plasma membrane. Is it correct? Yes. So cell wall, in that, which is the first formed layer in the cell wall? Is it middle lamellum? First formed layer in the cell wall. Is it middle lamellum, primary wall, or secondary wall? Which one? Which is your option? Which is your option? Very good. Primary wall. Very good. Very good. No, it's not middle lamellum, Madhumita. Not middle lamellum. It is primary wall. Okay. The first formed wall layer is middle lamellum. Now let us see among cell wall and plasma membrane. Yeah, it is second one, primary wall. Among the cell wall and plasma membrane, which is concerned with selective permeability? Among cell wall, next question. Among cell wall and plasma membrane. In these two, which is selectively permeable? Which shows selective permeability? Very good. Plasma membrane. Very good, very good. Yeah, Anand, very good. Very good, very good. Charita, very good, very good. Hasini, very good. So I think you all read that cell wall and the plasma membrane. Very good, Amma. Keep it up, keep it up. Now let us proceed to the next cell organelles. Okay, that is endomembrane system. Let us proceed with that. Today's topic, cell organelles. Cell organelles, membrane bound cell organelles, yes, they are present in eukaryotes or prokaryotes. In eukaryotes, membrane bound cell organelles are there, or in prokaryotes they are present. In the first class I told you prokaryotic cell. So in which cell we can see the membrane bound cell organelles? Is it like prokaryotic cell or eukaryotic cell? Very good, eukaryotes. Sairaj, very good. Ikshana, yes, very good. Lekhya, very good, very good. Keep it up. So these cell organelles are present in the eukaryotes. Where are they present? In the nucleus or in the cytoplasm? Where are they present? Nucleus or cytoplasm? They are present in? Okay. About your offline classes, yeah, you will get the information. Don't worry. Okay. Very good. Cytoplasm. So these are all present in the cytoplasm. Okay. And in the cytoplasm, you have various cell organelles. You have learnt in your 10th, I guess, or 9th class, where you are studying cytology. There, you have learned so many different cell organelles. Now, let us see some cell organelles which are together grouped as endomembrane system. endomembrane system. Today's topic is endomembrane system in the cell organelles. Endo means within, inside. Inside the cytoplasm, they contain membrane and they are all present in a group of system. You know, group of cell organelles, if they form one unit to perform particular functions together, then it is called as a system. So here endomembrane system is there. In the endomembrane system, we have the membrane bound cell organelles which are functioning like a group or a unit. So what are the cell organelles that are present in this endomembrane system means? The first one is called endoplasmic reticulum. In short, it is called as ER. The second one is called Golgi complex. And the third one is called lysosomes. And the last one finally, vacuoles. So all of you look at the board and tell me how many cell organelles are together present in the endomembrane system. Endomembrane system. How many cell organelles? The question is how many cell organelles? Very good, Venugopal, 4. Very good. Very good. Yes, Sairaj, very good. So all of you can see ER. Yes, very good. 4, Golgi complex, lysosomes, vacuoles. So there are 4 cell organelles which are together functioning as a system and their functions are coordinated. So they form the endomembrane system. Why they are forming a group means because their functions are coordinated. Functions are coordinated. Because of this, only these 4 will form a system. Remaining cell organelles, you know, mitochondria, chloroplast, other cell organelles, they will not be a part of this endomembrane system. And this total endomembrane system, 4 cell organelles, they are covered by a single membrane. This is an important point here. All of them are having single membrane. They are bounded by single membrane. So, how many membranes are there around the ER? 1. How many membranes are there around the Golgi complex? 1. How many membranes are there in the lysosomes around that? 1. And around the vacuoles also, how many membranes are there? Only 1. So, all these 4 cell organelles, they are single membrane bound and their functions are coordinated. So, they are grouped together in the endomembrane system, which will form inside the cytoplasm some membranes. Membranous system will be there. And each of them, they have their own individual structure and they have their own individual functions. So now let us see the first cell organelle in the endomembrane system, that is ER. So all of you can see here, I have taken the eukaryotic cell and this is the nucleus. This yellow color one is the nucleus. We will come to the nucleus at the end. Now this is the ER. You can see this red color and yellow color one with some granules is there. It is the rough endoplasmic reticulum. You can see here rough endoplasmic reticulum. Red color and yellow color are there and they have some granules on top of that. They are the ribosomes. And here the red color one is there without ribosomes. That is the smooth endoplasmic reticulum. So we have ER arranged next to the nucleus, or else I can say in this picture rough ER is continuation with the nuclear membrane. So rough ER will be having the ribosomes on that and it is in continuation with the nucleus. From the rough ER, you are having the smooth endoplasmic reticulum that is formed from that. Okay. Now, I hope all of you understood the location of ER. It is present next to the nuclear membrane. Rough ER will be in continuation with the nuclear membrane and smooth ER will be in continuation with the rough ER. The next one. You can see clearly here the nucleus, smooth endoplasmic reticulum. I hope all of you can see without ribosomes, and you can see here rough endoplasmic reticulum is having the ribosomes. These yellow ones are the ribosomes. So now all of you can tell me how many types of ER we have. How many types of ER are present? How many types? I have asked the number. 2. Very good. What are those 2? The first one is rough ER, rough endoplasmic reticulum. Very good. 2. Very good. 2 types are there. Very good. Very good. So in the 2 types, the first one is the rough endoplasmic reticulum and the second one is the smooth endoplasmic reticulum. Why it is called as rough endoplasmic reticulum? Why is it called as rough endoplasmic reticulum? What is there on the surface? What is there on the surface? Rough and smooth, yes, rough and smooth ER. Why rough ER is called rough? On them, what are present? Okay, proteins, lipids, very good. Ribosomes, yes, ribosomes. So, which ER is having the ribosomes? That is called as rough ER. So, the first type, ER, two types are there. Two types. First one is rough ER, rough endoplasmic reticulum. Second one is smooth endoplasmic reticulum. Rough ER always it will be having the ribosomes. It is studded with ribosomes. So, ribosomal containing ER is called as rough endoplasmic reticulum, and smooth ER is without ribosomes. There are no ribosomes on the surface of the ER. Then it is called as smooth ER. So, rough ER and smooth ER. These rough ER functions, as they are having the ribosomes which are studded on that, the main function of rough ER will be, RER is concerned with protein synthesis. RER function, it is concerned with protein synthesis. Then smooth ER, it is not having the ribosomes. So, this is mainly concerned with lipid synthesis and steroidal hormone synthesis. Lipids and steroidal hormones. Steroidal hormone synthesis. Synthesis of all these things, lipids and steroidal hormones. You know, steroidal hormones like estrogen, testosterone, these all will come under steroidal hormones. So, rough ER function is protein synthesis because they are having the ribosomes, and smooth ER function, as they don't have ribosomes, their function is lipid synthesis and steroidal hormones like estrogen, progesterone, testosterone. These hormonal synthesis will be done by the SER. So, this is about the two types of ER. And you can see in this picture, one more labeling is there, cisternae. Can you all see the cisternae? And cisternal space. So, these are the components of the ER. Let us see what are the components of the ER. In this picture only you have seen the ribosomes, smooth ER, rough ER, but you have cisternae. Cisternae are these flattened sacs, and in between that sacs we have a space, that empty space is there, which is called as lumen. Okay, let us go to the next one. So, here you can see that these are the components of ER. Components, parts, components of ER. Okay. So, in these components you can see these cisternae are there. These are flattened sacs. Very much flattened sacs, and you know you have seen the ribosomes are there. So, it is a part of rough ER. So, cisternae are just flattened sacs. Then vesicles, these are rounded structures, which are also studded with the ribosomes. Then these are branched structures, and these are called as tubules. So, there are three parts or components in the ER: cisternae, which are flattened sacs; vesicles, which are rounded sacs; then tubules, these are the branched tubular structures, and this is the tubules they are called as. So, three components are there: one cisternae, two vesicles, and third one is tubules. These three are the main components of the ER. Okay. Tell me how many components are there in the ER? How many components are there in the ER? How many? How many are there? Is it 1, 2, 3? Yes, Venugopal, very good, very good. Sairaj, very good. Madhu, yes, very good. Very good. Babu, yes. 3. In that 3, which are the flattened sacs? In that 3, which are the flattened sacs? The flattened sacs, which are called flattened sacs. Lucky, 1. What is 1? Okay, cisternae. Okay, fine. So, I have given you the numbers 1, 2, 3. Okay, which are the flattened sacs? 1. Okay, cisternae. Now, which are branch structures? Branch structures. Branch structures. Yeah, cisternae, correct. Flattened sacs. Okay, branch structures now. Which are the branched? Yeah, third one. Name of that. Name of that. Tubules. Yes, very good, very good, very good. Tubules. Very good. I hope all of you understood the ER. Endoplasmic reticulum, it is present next to the nuclear membrane, and two types of ERs are there. Rough ER, that ER is studded with ribosomes. Smooth ER, it is not studded with ribosomes. And rough ER is involved in the protein synthesis, and smooth ER is involved in the synthesis of lipids and the steroidal hormones. And the main components of ER are three components are there: flattened sacs called cisternae, and rounded structures called as vacuoles, and branch structures called as tubules. That's it about the ER. Okay, and you should remember one point, that these are network of tiny tubular structures. About the ER, I would like to add one point here. They appear under the microscope, network of tiny tubular structures. Or instead of network, you can write reticulum. Reticulum of tiny tubular structures is ER. They appear like reticulum network, and they are made up of tiny small tubular structures, and they are present next to the nuclear membrane. They are in continuation with the nuclear membrane. And the which ER will be continuation with the nuclear membrane is rough ER. And from rough ER, smooth ER will be originated. It will be connected like that. I hope all of you understood. Yes or no? Yes? Understood the ER? Have all understood? Okay. So, what is the second cell organelle in the endomembrane system? The first cell organelle in the endomembrane system is ER. Very good. Second cell organelle is Golgi complex. Now, let us see this Golgi complex. All of you can see Golgi apparatus or Golgi body, or you can call it as complex also. Golgi complex. Okay. There are too many different names for that same structure, like Golgi apparatus, Golgi complex, Golgi bodies, okay, dictyosomes, different names are there, but these are the main names. And you can see here, after the endoplasmic reticulum, you can see this is the endoplasmic reticulum, this is the nucleus, endoplasmic reticulum, and now this is the Golgi complex, the pink one which is there, that is near to the nucleus, is the Golgi complex or Golgi apparatus. This is how the Golgi apparatus will be looking. All of you can see this pink one which is here. This is enlarged view of the same structure. It is lying next to the ER and near to the nucleus only, not so much away. And this Golgi complex part, how this will be looking in under the microscope, you know? These ones will be looking like densely stained parts. Densely stained reticular structures. Dark color will be there, and they are the reticular structures, densely stained reticular structures which are found near to the ER and near to the nucleus. That is the Golgi complex. Now let us see the Golgi complex, enlarged view. This is the Golgi complex. You can see all of you here, like ER, this also has the cisternae. So can I say cisternae and vesicles are the parts of Golgi complex also? So vesicles you can see here and cisternae. So cisternae, same thing, flattened sacs, and you can see there is an empty cavity inside. This is the lumen. If you think that this is the cisternae, flattened sac, and this empty cavity is called as the lumen. So flattened sacs will be there. That sacs are little bit different from the ER. In the ER, they are just flat, like this, they are flat. But in the Golgi complex, their ends are little bit swollen, and they'll be having convex and concave side. Little bit difference is there between the cisternae of ER and the Golgi complex. In the ER, they are just flattened sacs. Whereas in the Golgi complex, their ends are curved or swollen. Swollen ends will be there for the cisternae. in both the empty cavity inside the cisternae is called as lumen only. And in these two major parts are the cisternae and vesicles. And because of the convex and concave sides, you can see that convex and concave sides will be there. Okay. This convex side is called cis phase or forming phase. Forming phase. Always it is connected to the ER, and from the ER incoming transport vesicle will be coming. It will be carrying so many things which has to be modified inside the Golgi complex. It will come from the cis phase or the forming phase, and it will be fusing with the cisternae. And it will be pouring all the contents into the cisternae. That will be coming through this lumen, and it will be undergoing the processing, and then it will be pinched off from the ends of the cisternae like this in the form of secretory vesicles. So forming phase or cis phase will be convex side, and trans phase or maturing phase, okay, or concave side will be present towards the plasma membrane. This side it is present towards the nucleus. This side it is present towards the plasma membrane. So whatever the substances that have to be modified from the ER, they'll be incoming in the form of transport vesicles, and they'll be added the cis phase or the forming phase or the convex phase of the Golgi complex, and that will be poured at the cis phase, and they are processed through these all the cisternae which are connected to one another. And after processing, after the modification, they'll be released from the swollen ends of this cisternae in the form of secretory vesicles. And the secretory vesicles will be released from the trans phase or maturing phase or concave phase. That side they'll be secreted. This is how the Golgi complex will be functioning in a cell. So can I say that this Golgi complex is doing the packaging of the contents after the modifications? After the modification, this is packaging everything in the form of secretory vesicles. So Golgi complex is mainly concerned with the functions like packaging center. It is involved in packaging. So this is the main function. So it is called as packaging center of this cell. What is the main function? That it is involved in packaging. So it is called as packaging center of the cell. Next function, it is involved in secretion because it is secreting so many vesicles from this trans phase. It is involved in secretion. That is the second function. Third function, do you remember in the plasma membrane that carbohydrates are present only on the outer side? I have told you, to the plasma membrane outer side some carbohydrates are present. They are called as, anyone, do you remember? Carbohydrates are present on the outer side of the plasma membrane. What is their name? What they are called as? Yeah, all subject corner, packaging, very good. But I am asking you, some carbohydrates are there present on the outer side of the plasma membrane. What are those carbohydrates called as? Carbohydrates. Peripheral, that is proteins. All subject corner, carbohydrate chains, yes. But I have given you name of that carbohydrate chains. Integral, peripheral, they are proteins. Yes, Deeptika, very good. Glycoprotein, the fiber glycoproteins, very good. Harika, very good. Yes. Dikshita, pathogen, no, it's not zoology class. Peripheral proteins, no. Histones, no. Glycolipid, yes. Yes. Soumyan, yes. Glycoprotein, Anand, glycolipid, yes. Correct, correct. Charita, glycolipids. Harika, glycoproteins, very good. So, the glycolipids and glycoproteins are synthesized by the Golgi complex. So I would like to give you three main functions. The first function is packaging of the different materials after the processing. So it is called as, its nickname is packaging center of this cell. Second function, it is involved in secretion because it will be secreting so many different materials. So it is called as secretory cell organelle. Secretory cell organelle. Third function, it is involved in the synthesis of glycoproteins and glycolipids. So with this, we have completed the Golgi complex, which is looking in the form of densely stained reticular structures. Densely stained reticular structures, and their components mainly are cisternae, vesicles. Tubules also will be there, but you can't see them because they are in between them. Okay, branch structures also will be there, but they are less. Cisternae, vesicles will be there. And always from the cis phase, incoming transport vesicle will be coming and added to the cisternae. And always from the trans phase, the secretory vesicles will be coming out after the processing. And cis phase is called forming phase and trans phase is called maturing phase. Newly forming vesicles will be sent to the target regions. Functions of Golgi: packaging center, secretion, and then glycoprotein and glycolipid synthesis. So we have completed 2 cell organelles of the endomembrane system, and I hope you understood that from the nuclear membrane first ER is coming, RER, smooth ER, and now smooth ER is connected to the Golgi complex, right? So their functions are coordinated. Whatever the ER materials are there for the processing, they will be sent to the Golgi complex. Yes, I hope all of you understood these 2 cell organelles. Yes, very good, very good. So how many cell organelles we have completed so far? ER and Golgi complex. But you know, in endomembrane system we have 4. So the third one is which one? Lekhya, third one. Very good, very good. Third one is lysosomes. The third cell organelle, yes, 2 we have completed, ER and Golgi complex. The third one, lysosomes. Lysosomes. So lysosomes, generally, these lysosomes are actually formed from the Golgi complex only. So I told you first, from the ER Golgi will be there, and from the Golgi the lysosomes are formed. So they are actually formed from Golgi complex. So these are the transport proteins which are coming from that rough ER. You know, rough ER will be synthesizing the proteins and it is involved in the transport of substances, Golgi complex, and they will come and attach here. And this lysosome is packed by the Golgi complex. And these lysosomes, they are having just a single membrane. One membrane is there. This is one membrane around them. And you know, all the cell organelles of endomembrane system will be having only one membrane. And that membrane bound structures and which contain hydrolytic enzymes. They all contain hydrolytic enzymes. Hydrolytic means by the adding water. Hydro means, you know, water. Lytic means breakdown. By adding water, they break down the substances. So different types of hydrolytic enzymes will be there, like, I will write here, carbohydrases. These are the enzymes which will break down the carbohydrates. So ase means it is an enzyme. Ases, suffix wherever you get, ases means enzymes. So carbohydrases means they break down they are the enzymes which will break down the carbohydrates. Now next enzymes are proteases. Proteases. They will break down which materials? Proteases. They break down which materials? Yes, suicidal cells, very good. Proteases, yeah, Jayashree, proteases are enzymes. They break down some materials. In that word only it will be there, what they break down. Proteins, very good Venugopal, very good, very good. Proteins, yes Sairaj, very good. Protein, Koteswarao, yes, proteins, yes Sanjana, proteins, very good, very good. So now I am going to write one more enzyme, you have to tell me what it will break down, okay. The third one, lipases. What they'll break down? Lipases. Yeah, proteases will break down proteins. Carbohydrates will break down carbohydrates. Lipases will break down, yes, yes, Chakri, very good. Lipids, Venugopal, very good. Lipids, Sairaj, Balu, yes, yes, Dheeraj, very good, very good. Keep it up. So lipases will be breaking down the lipids, very good. The last one, nucleases. Only these are the enzymes which you have in the syllabus, but yeah, different types of hydrolytic enzymes will be there. Yeah, fatty acids, yeah. Don't say fatty acids, lipids, because they'll break down the lipids. Okay, chakri, not nucleus. Nucleases will break down nucleic acids. They function on the nucleic acids like DNA and RNA. They break down DNA and RNA. So nucleases are the enzymes which will break down nucleic acids. Okay, so all these four will come under the hydrolytic enzymes. Hydrolytic enzymes. So the enzymes which will break down different molecules, biomolecules, by adding water. And all of them will be present inside this single membrane sac, which is called as lysosome. And these ones will be having generally acidic pH. You know, acidic pH 1 to 2 will be there in this. Acidic pH will be there, that is 1 to 2. Okay. So lysosomes are single membrane bound sacs. They are formed from Golgi complex and they contain hydrolytic enzymes. And that hydrolytic enzymes types are carbohydrases, which will break down carbohydrates, proteases, which will break down proteins, lipases, which will break down lipids, nucleases, which will break down the nucleic acids like DNA and RNA. That's all about the lysosomes. I hope all of you understood. Yes? Yes? Any doubts up to now? Yes. Have you all understood? Yes, Dheeraj, very good. Yes, do respond. Yes, yes. Kotisra, Lekya, yes. Yes, yes. Very good, very good, very good. Okay. Which is multinuclear. We haven't gone to the nucleus, no, yet. It is not having any nucleus. These are all enzymes. These are all enzymes. They contain just a bag which contain enzymes. It's not nucleus. Okay, very good. Let us go to the last cell organelle of today's class. That is vacuole. Okay, the last one. Yes, vacuole. So this vacuole, I have taken the plant cell vacuole here. In the plant cell vacuole I have taken. Vacuoles are present in different cells also, like amoeba. Amoeba will have, and different animals also will be having the vacuoles. Now let us see this one. Plant cell vacuole, it is having a membrane which is called as tonoplast. Tonoplast is the membrane of the vacuole. So what is the membrane of the vacuole called as? Tonoplast. It encloses a membrane bound space in the cytoplasm. Whatever this space is there, it is a part of cytoplasm only, but it is surrounded by a membrane. So vacuoles are membrane bound spaces in the cytoplasm. Membrane bound spaces in the cytoplasm are called vacuoles. And in the plant cell generally, it can reach up to 90% of the volume of a cell. See, if a cell has 100% of the volume, then 90% of the volume can be utilized by the vacuole itself. And in that vacuole, the membrane is there. That membrane is called as tonoplast. And this inside one, that is called as tonoplasm or cell sap. Tonoplasm or cell sap. So tonoplast will be around the vacuole, and inside the vacuole, inside the tonoplast, we are having so many things will be there, that together it is called as tonoplasm or cell sap. And in this tonoplasm or in the cell sap, you know what materials will be there? Like water. Water is present. Okay. Then sap is present. Sap is made up of different kinds of materials that will be there inside this. Then it will be having excretory materials. Whatever the excretory products are there, that excretory products are also present here. And the substances which are not used by the cell are also present. Useless substances for the cells. Useless substances are also present here. So inside the tonoplasm, we are having water, sap, okay, excretory materials. Then we have the useless substances which are not used by the cell that are also present, and some kind of ions will be there, and even sometimes it contains one particular pigment also, anthocyanin, like that all of them will be there in the tonoplasm. particularly in the plant cell, and it can occupy 90% of the volume of this cell. And this vacuole, different types are there. So, types of vacuoles. The first one, sap vacuoles, which are filled with sap, and these are only called as plant vacuoles. They are present in the plant, so they are the plant vacuoles. Second one, contractile vacuoles. Contractile vacuoles. Then third one, food vacuoles. Then fourth one, gas vacuoles. Okay. So contractile vacuoles are present in amoeba, euglena, paramecium, etc. And the function of this contractile vacuole is concerned with osmoregulation and excretion. Osmoregulation and excretion. They are the functions of contractile vacuole. Food vacuoles are concerned with digestion of food. Okay, that is the main function of food vacuoles. Gas vacuoles, they store air, they store gas and helps in buoyancy. Buoyancy means floating on the water. So they help in floating on the water surface, that is buoyancy. So these vacuoles are different types are there in different organisms and they do different functions. And about this, how they are formed. All of you can see here. See here how they are formed is endoplasmic reticulum is there. This is the rough endoplasmic reticulum which is there. Next, it is having connection with the Golgi apparatus. Okay, cytoplasm cell membrane is there. And from the Golgi complex, you can see these lysosomes are coming out. They are formed from the maturing phase of the Golgi complex. The lysosomes are formed. And that lysosomes are getting connected to the food particles are entering here by the endocytosis process and they are forming the food vacuole. And that food vacuole is mixing with the lysosomes. It will form digestive vacuole where the food will be digested and digested food is absorbed into the cell cytoplasm and waste materials are removed from the cell by exocytosis and elimination. So this is how all of their functions are coordinated with one another. ER is coordinating with the Golgi complex. Golgi complex is coordinating. It is releasing the lysosomes and lysosomes are meeting the vacuoles, food vacuoles, and they are concerned with the digestion and elimination of that waste. So these four cell organelles, as they are connected with one another and their functions are coordinated, they together form endomembrane system. And you should remember that endoplasmic reticulum, different functions you have learned for the endoplasmic reticulum as I gave you. But endoplasmic reticulum is meant for intracellular transport. Intracellular transport, that is the main function of ER. Golgi complex main function, you know, packaging and secretion. Packaging and secretion. Whereas lysosomes main function, lysosomes, they are called suicide bags of this cell. Bags of this cell, because they will kill all the cell organelles, old worn out cell organelles, or if any pathogen comes, all of them will be killed by the lysosomes. So they kill their own cell contents also, that is why they are called as suicide bags of the cell. Then vacuoles, these vacuoles are called as Vacuoles are called as storehouses of this cell or repository of this cell. Storehouses of this cell, or you can call it as repository of this cell, because it will be containing so many ions. It will be storing all the waste materials, excretory materials, ions, and different things will be stored in that vacuole. That is why they are called storehouses of this cell or repository of this cell. Only these 4 cell organelle functions are coordinated with one another and they form endomembrane system. So I have given you individually their functions also. ER, reticular tiny tubular structures, densely stained bodies in the cytoplasm, packaging and secretion their function. Lysosomes, they are filled with hydrolytic enzymes, so they can digest anything, so they are called suicide bags of this cell. Vacuoles, they are filled with useless materials, waste materials, and some kind of ions, okay, whatever the extra materials, water, pigments, extra materials are there, all of them will be stored inside it. So they are called as storehouse of this cell or repository of this cell. I hope all of you understood. Yes, students, have all understood? If you have any doubts, you can ask me. Any doubts? Yes, Sai, yeah, Diptika, yes. Understood everything? Kritika, no ma'am. For what? No. All clear. Chakri, very good. Swati, good. Yeah, if you have any doubts, you can type there. If you understood everything, okay, you have to read only this much today, and tomorrow we'll continue with the next cell organelles. If you have any doubts, you can ask now. No doubts. Okay, good. We'll end with 2 questions. Very good. Give a thumbs up, all of you, if you understood. Okay, very good. Let me ask you 2 questions. Okay, just 2 questions. Yeah, 2 questions. Name the cell organelle which is called as packaging center of this cell. Packaging center of this cell. Very good. Packaging center of this cell. Among these 4. Very good. Golgi, Golgi, very good, very good. Golgi complex, good. Okay, next question. Which are called suicide bags of this cell? Suicide bags of this cell. Suicide bags of this cell. Bags of this cell, suicide bags, very good. Syed, yes. Pallavi, lysosomes, yes, yes, very good. Very good. Among these 4 cell organelles, which is concerned with storing different materials? Storehouses of this cell. Among these 4. Storehouses of this cell. Which are that? No, not lysosomes. Lysosomes over. Yes, vacuole. Lekya, very good. Vacuoles, vacuoles. Storehouse of the cell or vacuoles. Very good. Okay, the last one. How many membranes are there around all these 4 cell organelles? 1, 2, 3. How many membranes are there? Around ER, around Golgi, around lysosomes, around vacuoles. How many membranes are there? 1. Very good. Single membrane bound. Very good, very good, very good. Okay. Which cell organelle is concerned with, the last one, which cell organelle is concerned with transport of substances? Transport inside the cell. ER, Golgi, lysosomes, vacuoles. Which one? ER, very good, very good. Intracellular transport. Okay, the last one. Which cell organelle is concerned with protein synthesis and lipid synthesis? Protein synthesis and lipid synthesis. ER, very good, very good. ER. Correct, correct, correct. The last one. Last one. The membrane of the vacuole is called as? The membrane of the vacuole is called as? Golgi, no, ER. Membrane of the vacuole. What is the name of the membrane of the vacuole? Is it tonoplasm or tonoplast? Very good, tonoplast. Very good, very good. Yeah, I hope all of you understood. Yes. So next class we'll continue with the cell organelles. Yes. If you have understood everything, give a thumbs up. Okay. Yes, very good, very good. Tomorrow I'll ask the questions and then we'll continue with the next cell organelles. Yes. Okay guys, bye ma. See you until tomorrow. Bye.
Hello everyone. Hello my lovely kids. How are you all? Good morning, good morning, good morning everyone. Good morning Shravani, beta, I'm all good. I'm fine. How are you all? Good morning Sunil, Charita, Gopal, Deeptika, Shravan, Balu, Charvik, Akhila, Veda, Ritvik, Kedar, Suprita, Swati, Dheeraj, Hemant, Ajay, Swati, Sai Raj, Yashu, Pinky, Sushant, good morning, thank you. Deepti, good morning beta. Sai Raj, Swati, Sanjana. All right everyone, good morning all of you, each and every one of you, a very good morning, and let us start today's class. Okay, your name is Kedar. Okay, all right beta, all right. I will try to remember. Thank you beta Jeevan. All right everyone. Good to see you all also too. Okay, good to see you too. Viber. All right everyone. All right everyone, let us start today's class. Let us start today's class, and in today's class, I won't be teaching actually today ecology. I will be just, I will make you comfortable with ecology today. Okay, because when we start teaching ecology, and even if when we are completed with the ecology, the students face difficulty. They feel that it is a very boring unit. Okay, but let me tell you clearly, it is not at all boring. Okay everyone, now stop chatting and listen to me. It is very important that we should connect to the chapter. If we won't connect to the chapter then we will not find it interesting. And if we don't find something interesting, we don't see it at all, we don't read it at all, we don't look into that, and we don't look forward to understand that. Okay, so today I am going to make you comfortable with ecology. And let me tell you that NTA has made it very easy for us now. If you see the NEET syllabus, ecology unit, so much has been reduced beta, so much has been reduced. First of all, let me just tell you which are the chapters in the ecology. Okay, ecology is a unit. This ecology is given in the class 12th NCERT beta. So you have to see it into the class 12th NCERT. Yes, Kritika, yes. I am going to repeat these classes, all of these classes in the campus I am going to repeat beta. Because here I have not, I have not covered every topic in very much detail. I am simply giving you the brief introduction, or I am making you comfortable with the topics. Okay, so that when we will teach it here, then you will understand it better. Okay, so now everyone, let me tell you that in ecology previously, beta, this is the old NCERT which I am showing you here. Kedar beta, we will communicate about the offline classes soon. Okay, we will communicate about the offline classes soon. So now you just stay calm, stay patient, and just just attend these classes. Okay, focus on these classes now. Okay everyone, so this is the beta old NCERT. This is old NCERT. This one is old NCERT. This one is old NCERT. Old NCERT. And beta, this is new NCERT. This is new NCERT. If you will see old NCERT, you will find how many chapters? You will find 4 chapters in ecology. 4 chapters. 4 chapters beta. So completely one chapter has been removed, and that is environmental issues beta. This chapter have been removed completely for the NEET exam. In the NEET syllabus, they won't ask questions from the environmental issues. Okay, you must be knowing that the syllabus have been updated for the NEET 2024, and that will be the syllabus for the NEET 2025 or 2026 also. You will be appearing in 2026, right? So environmental issues we don't have to study. Okay, now if we talk about these 3 chapters, I will tell you the reduction of the syllabus in these 3 chapters also. Previously, organisms and population chapter beta, it was, it was so much of the syllabus was there. Now, only one topic is there. That's it. I will show you. Ecosystem also, many topics have been removed. Many topics have been removed. Biodiversity and conservation, it is as it is, no reduction is there. It is the complete chapter, you have to study the complete chapter. Okay, complete chapter. Now let me show you organisms and population first of all. Organisms and population, old NCERT. This is from old NCERT beta. This is from old NCERT and this is from new NCERT. This is from new NCERT. Beta, in old NCERT, there is one topic, organisms and its environment, and another topic is population. Now we don't have to study this topic, organisms and its environment, because there was so much in this topic. There were so many things in this topic, and now we don't have to study all those things in the organism and its environment. So now we have to study only about population. Now we have to study only and only about population. So in the very first chapter, organisms and population, this is the very first chapter of the ecology unit, and we have to study only which topic beta? Populations. That's it. Okay, very easy. It is going to be very, very easy beta. Now coming to the next chapter, the second chapter, that is ecosystem. Yes, you are very familiar with this chapter. Yes or no, everyone? Have you studied about ecosystem before? Yes, tell me in the chat section. Have you studied about the ecosystem? Sushant, ma'am, we will get textbook in college or we have to buy online. Okay, beta, I think you will get it here only. But I think NCERTs you have to buy. But the other study material which is from Sri Chaitanya only we are providing, that you will get it from here only. Okay, yes. Everyone knows about ecosystem. Alright. So this is going to be a very, very easy chapter. See, first chapter is going to be very, very easy because only one topic we have to study, that is populations. Second chapter, you already know about it. Okay. Everyone is saying yes. That means you know about what is ecosystem and what all are the things in the ecosystem, you know briefly. Okay, you know at least few things about the ecosystem. So now, if you compare beta, previously these ecological succession, nutrient cycle and ecosystem services, these 3 more topics were there. If you compare, this is the old NCERT beta, this is old NCERT again, and this is new NCERT. This is new NCERT. So if you compare old NCERT with new NCERT, only these topics now we have to study, only these. We have to study only these. Only study these, okay. We don't have to study ecological succession, nutrient cycle, ecosystem services. So again NTA has made this easy, okay, made this easy for us, okay. Now coming to the biodiversity and conservation, the third chapter, biodiversity and conservation, is the third chapter of the ecology beta. In this, we have to study about the biodiversity and the biodiversity conservation. We have to study both the topics, nothing is deleted, okay, nothing is reduced, okay. Animal tissues is not there in new NCERT, but in NEET syllabus. Yes, absolutely correct beta. Ecology, for ecology, you have to follow new NCERT. For animal tissues, you have to follow old NCERT. Okay, we will be guiding you in every chapter, okay, and sometimes there are some topics beta which we are teaching so that you will understand the other topics properly, and what we are teaching, maybe it is not in the NEET syllabus, but why we are teaching, because then you will understand the other topics, the further topics properly, okay. So just leave it on us, just trust your teacher. Yes or no? Just trust your teacher. Your teacher will be guiding you. Your teacher will be guiding you in every chapter. How you have to prepare that chapter. How in easy way you can learn the chapter. I will be giving you the the mind maps. Before starting the chapter only, I will be telling you that what all you are going to study in this chapter. When you have a mind map in your mind about every chapter, remember, it is very easy for you. Okay, it is very easy for you to understand, to learn, okay, and to revise. Okay, so yes, everyone, I know you people trust me. Okay, now let me introduce you to the ecology beta. Ecology is very, very easy. Ecology is, now listen to me very carefully. Okay, thank you everyone. Now listen to me very, carefully. Ecology is something which we observe, which is happening with us. Here, we are studying ecology. Ecology is there in between us. How come? Because ecology is the study of, yes or no? Ecology is the study of. Let me just quickly define ecology. Beta, ecology is the study of interaction. Ecology is the study of interaction. Study of interaction among organisms and its physical environment. Among organisms and its physical environment. What it means, beta? What it means? Interaction among organisms and also the interaction of organisms and its physical environment. What is the meaning? See, I am your teacher, you are my students. We are interacting or not? I am an organism, you are an organism. Yes or no, everyone? What is the meaning of an organism? What is the meaning of an organism? Organism is an individual, beta. Organism is an individual which belongs to a species. An individual belongs to a particular species. A particular species. So you are an organism. You all are an individual organism. I am an organism. Okay. So every one of us, if you have a dog in your house, that dog is an organism. If you have a cat in your house, that cat is an organism. Okay. If you have a rat in your house, so rat is an organism. If you have cockroaches in your house, cockroach is an organism. Okay. If you have a tree in your house, tree is an organism. Are you understanding what is the meaning of organism, everyone? Yes, let's be active in the chat section and let's give a thumbs up. Yes or no? Please give a thumbs up if you are understanding each and every point which I am telling you. Yes, everyone. So all of us are organisms. Okay. Now, this won't be a class if you won't interact with me and I won't interact with you. There is a need of interaction. Yes or no, everyone? We need to interact. We need to interact with each other. This is the need of the organism. Have you ever seen that at a place only one organism is there and any other organism is not there? Have you ever seen that? Have you ever seen that? Have you ever thought of it that there can be a place where I can go and live alone and nobody should be there? Beta, you cannot live alone. Okay, you cannot live alone. You need any other organism. You need any other organism, be it of your own species or be it of different species. Okay, so now you understood what is an organism. Now let us understand interaction in between the organism. Ratna, what beta, what you have not understood? Okay, have you understood everything? Okay, I have only told you the definition of ecology and the meaning of organism. Okay, now yes, there is a need of interaction. Okay, I need to interact with the organisms which are present in my surrounding. Similarly, you also have to interact with the organisms which are present in your surrounding. For example, if there is a cat around me, if there is a rat around me, if there is a cockroach around me, if there is a rat, I will run away. If there is a snake, I will run away. So this is my interaction. Okay, this is my interaction. Yes, we all are dependent on each other. Yes, yes, Deepti beta. So if and I also run away. I will also run away if I will see a dog also. Let me tell you, I have a phobia of dogs. Okay. So some people, they love dogs very much. So that is their interaction with them. I don't love animals. Okay. I'm not an animal lover. I love animals only for, if I look at them, they seem cute to me and that's it. But I cannot go, near to animals and I cannot touch them. I don't know. I have a phobia kind of a thing. So that is my interaction. If I will see a dog, a cat, a rat or a cockroach, I will run away. Or else if my son, I have a son, okay, if my son will see, any cockroach in the house, he will just step on it. He will just step on it and kill it. That is his interaction with the cockroach. Are you understanding? It is his interaction with the cockroach. So every one of us are interacting with the organisms. Okay. If I want to buy fruits, if I want to buy vegetables, I will go to the market and interact. So are you understanding? Ma'am, are you for boys campus? Beta, I am teaching in the girls campus. Okay. I am teaching in the girls campus, Viber. Alright, everyone. Now, you understood that interaction among the organisms. You understood this. Interaction among organisms. Organisms can be of different species, right? I belong to Homo sapiens. Dog has a different species. Cat has a different species. But we all are interacting. Okay? We all are interacting. Now, among the physical environment, for example, I am, feeling very hot. So I will tell somebody to switch on the AC because now this is my interaction with the temperature beta. But let us suppose I am feeling very cold. Okay. So I will tell to somebody that you please switch off the AC. This is my interaction with what? With the physical environment around me. This physical environment, this temperature, the soil, the rain, all these things are making the physical environment beta. Yes, the kids, they are going to the playground. They are playing in the soil. So they are interacting with the soil. Yes or no? Yes or no? They are interacting with the sunlight. They are interacting with the rain. When, how many of you love rain? I love rain. I love rain. So rain is a physical environment, abiotic factor. Okay. So yes, we are interacting. Yes, we are interacting with the abiotic factors as well. We are not only interacting with each other, we are also interacting with the physical environment around us. Okay, so that is what is ecology. Study of interaction among organisms and its physical environment. Okay. So how many of you have understood the meaning of ecology? In ecology, we are studying the interaction among ourselves, among the organisms, and in between the organism and its physical environment. Yes or no? Afia, thank you, beta. How many of you have understood? Please give a thumbs up. And if you have understood very nicely, give a heart. Yes. Yes, we are interacting with air, we are interacting with soil, we are interacting with rain, we are interacting with temperature, we are interacting with all these abiotic factors. Yes, everyone. Yes, everyone. Thank you. Okay. Now, ecology has, 4 levels. Ecology has 4 levels, 4 main levels. At 4 main levels, we will understand ecology. Okay. So what are the 4 main levels, beta? 4 levels, 4 important levels, 4 levels. Ecology is concerned with 4 levels, beta. First is the organism. First is the organism, beta. Second is the population. I will tell you what is the meaning of a population. Second is population. Third is beta, third is community. Third is community. And fourth is beta, fourth is the biome. I will tell you each and everything. What is the meaning of each and everything? Okay. Organism means an individual belong to a particular species. Okay. Organism means it is an individual belonging to a particular species. Let me talk about population now. let me now talk about population, beta. Population. So first you listen to the definition. Population is the group of, thank you beta, now concentrate on the topic. Population is the group of organisms of same species. Population is the group of organisms of same species. Group of organisms of same species, beta. Same species. So all of my students are making one population. All of my students are making one population. Thank you, Suprita. Now, everyone, listen to me. All of you are belonging to one species? Yes or no? All of you are belonging to one species? All of you are making a group? You will be present in my class in a group? Yes or no? You will be present in my class in a group. So, you are one population. Okay, everyone? So, you are one population. Suprita, thank you, beta. Now, just concentrate on the lecture. So, you are making one population. Okay. Okay. But, can you tell me that only the existence of one population is possible? Anywhere existence of one population is possible or not? Yes, in my house, we are 3 members. So, we are 3 members, right? But 3 members of human species, beta. Me, my husband and my kid. Me, my husband and my son. We are 3 members. So, there is one population of humans. In my house, there is one population of humans, everyone. In all of your houses also, there will be one population of human. Yes, we will say one population of human. But in all of our houses, there can be mosquitoes. Yes or no? Mosquitoes will be there or not? House flies will be there or not? Lizard will be there or not? Rat will be there or not? If we have any pet, that can be a cat or a dog. Yes or not, everyone? Yes or no? So, in every one of our houses, in our home, we are one population or we are many populations? Yes, we will be many population. In one house, there will be a population of humans. There will be a population of humans. There will be a population of mosquitoes. There will be a population of mosquitoes. There will be a population of lizard. There will be a population of cockroach. There will be a population of cockroach. You can tell me anything else if there is in your house. You can tell me anything else. Okay. So, we will be many populations. Yes, absolutely. In every one of our houses, we have many. Frog? Who has frog in their houses, beta? Who has frog in their houses? Ants. Yes, ants is correct. Ants. One population of ants can be there. One population of ants can be there. Yes, house flies. I have not written house flies. Okay, let me write house fly also. One population of house fly. One population of house flies. Okay, anything else? Anything else? Fish. Okay, fish is also there in your house. Tanmaya. Okay, okay. Dog, yes, dog. I have told you, na, dog. Yes, plants of many species can be there. Okay, one population of dog. Okay, this is, so you understood population, but now you also understood one thing. Now you understood one more thing. Yes, I also have indoor plants as well as outdoor plants. Yes. Cats, snakes, oh my god, who has snakes in their house, beta? Kappa, I know kappa is frog. This much Telugu I know. Kappa is frog. Alright everyone. Now, just relate all these things. See, ecology is very interesting, na? Are you finding ecology interesting, everyone? Are you finding ecology interesting? Yes, it is absolutely interesting. See now, whenever group of population is there in our house, we have group of population. Means we have a population of human, we have a population of lizard, we have a population of mosquito, we have a population of housefly, we have a population of ant. Okay, all these I have written. So when so many populations are living together, we are making community. That is the third level of the biological organization. Ecology is concerned with 4 levels of biological organization. Okay, so community, let us write community beta. Community. So community means what? Community means group of populations, group of populations. Beta, till here we are only talking about living things. Till here, organism, population, community. Till here, we are only talking about living things, living organisms, be it a plant, be it a living organism, okay. But till here, we are not talking about the abiotic factors. Till here, we are not talking about the non-living things. But yes, we do have the non-living things also in our house now. We do have the non-living things also in our house. So we are interacting with those things also. That makes an ecosystem. When community interacts with abiotic factors, that is ecosystem beta. So in ecosystem only, we talk about both the things. In ecosystem only, we talk about both the things, biotic and abiotic factors. Okay. So in an ecosystem, we can write ecosystem is a community interacting with abiotic factors. Community interacting with abiotic factors. What are the major abiotic factors? Major abiotic factors are water beta, temperature, okay, light, soil. These are the major abiotic factors. Light, temperature, water, soil, air. All these are the major abiotic factors. Yes, wind. Okay, wind. These are the beta major abiotic factors. So we are interacting with the temperature, we are interacting with the water. Water is the most important abiotic factor. Jal hi jeevan hai. Yes or no? So water is the most important abiotic factor beta. If somebody will ask you what is the most important abiotic factor, that is water. Without water we cannot live. Why? Because the first life, when the first life came on this planet Earth, okay, you will study this in evolution chapter. Okay, so when the first life came on this planet Earth, beta, it was formed in water only. It was formed in water medium only. The first life. That is why, because of the availability of water on this planet Earth, life is existing on this planet. Why life is not existing on other planets? Because there is no water. And here on this planet, on this Earth, we have water, right? So we are lucky to have water, and that is why we are interacting with the water. We are drinking water, we are taking bath with water, we are, washing our utensils, our clothes, for cleaning of the house, for everything we require water. Yes or no, everyone? Yes or no, everyone? So now, okay, Shravani, ma'am, what is the difference between community and population? Beta, in population, we are telling one population. Group of organisms of same species is one population. But when so many populations are present together, we will say community. So my society is a community. My house is a community. In my house, we have different population. We have a population of human, we have a population of mosquito, we have a population of lizard, we have a population of housefly. So many population, when they are present together, that will be a community beta. Many population together makes the community. And when the community interacts with the abiotic factors, it is known as ecosystem, which is the second chapter. So in this chapter, we won't be talking about ecosystem. And remember, ecosystem is not among the 4 levels. Remember, ecosystem is not among the 4 levels. Okay, then come the biome. Okay, let me explain you biome beta. Let me now explain you biome. So after ecosystem, I am going to explain you biome. What is biome? See everyone, what are the 4 levels of biological organization? Organism, population, community and biome. Ecosystem is not among the 4 levels of biological organization. The 4 levels of biological organization are organism, population, community and biome. You understood organism, you understood population, you understood community. Till community we are talking about living things, living factors, okay. We are talking about only living things. But in a community, in a ecosystem, we are talking about non-living things also. See here, we are talking about non-living things also. Abiotic factors, these are non-living things. These all are non-living things, beta. So when community interacts with abiotic factors, so can we say in a ecosystem you will find biotic as well as abiotic factors? But we cannot say in a community you will find biotic and abiotic factors. Okay, we cannot say that in a community you will find biotic and abiotic factors. Only biotic. We will count only biotic things. Biotic, living. In an ecosystem, biotic as well as abiotic factors. So now let me explain you biome. What is a biome, beta? What is a biome? See everyone, group of ecosystems is biome, beta. Group of ecosystem. Biome is that large area where many ecosystems can exist. And these ecosystems will have the same climatic factors. For example, temperature. For example, rainfall. I will explain you with the help of the one diagram, one example. I will explain you with the help of the example. Okay, so biome, let us first write what is biome. Biome is a large area, where more than one ecosystem can exist and they have common climatic factor, or they have same climatic condition. Exist having more than one ecosystem, beta, more than one ecosystem, a large area where more than one ecosystem can exist and having similar climatic conditions. In these similar climatic conditions, the major 2 conditions are beta temperature and beta rainfall. Temperature and rainfall. Somewhere it will be rainfall, at some places it will be snowfall. So we can also call it precipitation. So now let me take the example. Okay. Let us suppose this is a sparrow. Let us suppose there is a dog. Let us suppose there is a cat. Let us suppose there is a lizard. Okay, let us suppose there is a housefly. Okay, let us suppose there is a human. Everything is an organism. Yes or no, everyone? Everything is an organism. Sparrow is an organism. Dog is an organism. Cat is an organism. Housefly is an organism. Human is an organism. Lizard is an organism. Okay? Lizard is an organism. Dog is an organism. Yes or no? Yes or no? So everything which I have put into the box, that is an organism, beta. That is an organism. Now let us suppose there are so many humans. Okay, many humans are there. These all are my students. Let us suppose these all have come to study from Madhu ma'am. Okay, so I am teaching you. Okay, these all are humans, beta. These all are humans. So this whole group will be one population. Yes or no? This whole group will be one population. This is one population, beta. Yes or no? This is one population. Now, let me make one human here. Let me make one sparrow here. Okay, I don't know how to draw a cat or dog, like I will take time in that. Okay, so let me just write one dog is there. Okay, this is one sparrow I have made. This is then one lizard. Okay, when all these things are present together, so human, dog, sparrow, lizard, cat is there, right, rat is there. When all these things are present together, beta, then can I tell that this is a community? This is a community. Yes or no? This is a community. This is a community. Community. Are you understanding now? Then what I am making here, there is a tree. There is a tree. In this tree, there are some fruits. Okay, there are some sparrows, there are some insects. Insects are there. Okay, this tree is there. Then here, soil is there. Yes or no? This is the soil, beta. Soil is there. Then what is happening? Rainfall is happening. So, rainfall is happening. Rainfall is happening. Okay, rainfall is happening. Soil is there. I have made soil. I have made rainfall. I have made rainfall. I have made this soil. Okay, sun is there. Sun is there. And from the sun, sunlight is coming. Sunlight is coming. Sun is the source of the energy. So, sunlight is there. Yes or no, everyone? Can I tell that I have made a terrestrial ecosystem? Yes or no? Can I say that I have made a terrestrial ecosystem? Yes or no, everyone? Can I say that this is a terrestrial ecosystem? This is a terrestrial ecosystem. Terrestrial ecosystem. So, are you understanding organism, population, community and ecosystem? In organism, I have not talked about any abiotic factor. In population, I have not talked about abiotic factor. In community, I have not talked about abiotic factor. But in ecosystem, I have talked about abiotic factors like soil, like rainfall, like sunlight. You understood. Now coming to biome. This whole is a area. This whole is a forest. Let us suppose this is a forest. Beta, this is a forest. Okay, in this forest, so many trees are there. All these trees are making the ecosystem. Yes or no? All these trees are making the terrestrial ecosystem. Why? Because ecosystem means living plus non-living things. Here, soil is there. Trees are growing in the soil. Sunlight is coming, trees are doing photosynthesis, right? Then insects are there, birds are there, okay? Some animals are there which are dependent upon the fruits they are getting from this soil, from this tree, okay? Some animals are grazing upon the leaves of this tree, okay? Okay, now here you will see one pond, beta. You will see one water body. Pond is there. This is pond is there. Pond. In the pond, you will see aquatic plants. You will see aquatic animals. Yes or no? You will see aquatic insects. Insects also you will see, right? Then here also sunlight from the sun. So, sun is giving sunlight to this also, sun is giving sunlight to this also. When rainfall will come for this also, the same, because they are present in the same area, beta. Same area they are present. So, rainfall is coming. The temperature in which this terrestrial ecosystem is present and this aquatic ecosystem is present. Pond is an aquatic ecosystem. So in this forest only this pond is there. So can we call that this forest is a biome? Can we call that this forest is a biome, beta? This is a biome. This is a biome. Biome is a large area in which more than one ecosystems can exist, and these ecosystems are sharing. They have a common climatic condition. They have a common rainfall. They have common temperature. The living organisms here also, for them also the temperature is same. The living organisms here also the same. Okay, don't go with the drawing, just focus on the understanding part. A large area in which more than one ecosystem exists. Yes, absolutely, Balu. Yes, absolutely correct. So you have to remember 4 levels of biological organization: organism, population, community and biome. So to make you understand biome, I have told ecosystem also. Okay. So yes, I know time aipo indi, Subhashini. Yes, I know time aipo indi. But you don't have, you have lots of time. Okay. Okay. I know that you can spare your time for me. Yes or no? Okay. So that was all about my class today. I hope you guys are comfortable with ecology now. I hope you guys are comfortable with ecology because in ecology, in the whole ecology, we will be talking about organisms and population and ecosystem, okay, all these things. So yes, Shreyash, I cannot continue for one more hour, beta. Obviously, I also have classes after the lunch break. So you now can go for your lunch. I will also go and see you tomorrow. Okay, tomorrow I will be teaching you a very interesting topic, that is population interactions. It is going to be very, very interesting. Okay, so now, for now, this is the end of the class. Hit the like button and subscribe to the channel, those who have not yet subscribed. Okay, so see you tomorrow. Bye bye. Take care. God bless you all.